Hi, today we are going to learn about identifying quadrilaterals given coordinates graphing. Let's look at a problem. Name the quadrilateral given the coordinates -1, -5, 4, 3, 12, 8 and 7, 0. Let me take this point as A, this as B, this as C and this as D. Now these points can be taken in ordered pair as x, y. So it means for point A the x coordinate will be -1 and y coordinate will be -5. This is our ordered pair. So let us plot these points on the graph. -1, -5 will be here, this point. I'll put a small dot. A. 4, 3. This point here. 4 on the x-axis and 3 on the y-axis. This is B. 12, 8. 12 on the x-axis and 8 on the y-axis. Here C and 7, 0. This will be point D. Let us join them together in order to form the quadrilateral. Let me draw a straight line. So this is the quadrilateral ABCD. A is here -1, -5. B is 4, 3. C is 12, 8 and D is 7, 0. Now, in order to find the lengths of these sides, we need to use the distance formula. Now, for any line whose endpoints are given by x1, y1 and x2, y2, the distance formula is given by square root x2 minus x1 whole square plus y2 minus y1 whole square. This is the distance formula to find length of any side. So we can determine the length of AB. Let's apply the distance formula. So length of AB will be square root of y2 minus y1. Let me take here y2, x2, y2, x1, y1. So we can take any coordinate to be x1, y1 and any coordinate to be x2, y2. That's up to us. So x2 minus x1 whole square means 4 minus -1 squared plus y2 minus y1 squared means 3 minus -5 squared whole squared. This is equal to square root of 4 plus 1 squared plus 3 plus 5 squared, which is equal to square root of 5 square plus 8 square, which is square root 25 plus 64, which is equal to square root of 89. Similarly, we can find the lengths of the other sides, that is BC, taking the coordinates 4, 3 and 12, 8, CD taking the coordinates 12, 8 and 7, 0, and AD taking the coordinates -1, -5 and 7, 0. And you will find that all these lengths equal to square root 89. So we can say AB is equal to square root 89 is equal to BC is equal to CD is equal to AD. So all the sides of this quadrilateral are equal. It means it cannot be a rectangle, it cannot be a parallelogram. Since rectangle and parallelogram have only opposite sides equal. So it has to be either a square or a rhombus. Now the difference between a square and a rhombus will be the diagonals of a square are equal, whereas diagonals of a rhombus are not equal. So we can find the diagonals also. BD and AC. By using the distance formula only, we will apply the distance formula. For BD, the coordinates will be B is 4, 3 and D is 7, 0. And for AC, they will be A -1, -5 and C is 12, 8. When you will apply the distance formula, you will find that length of BD is 3 square root 2 and length of AC is 13 square root 2. We can say units everywhere. So since the diagonals are not equal to each other, therefore we will say that ABCD is a rhombus, which is the answer in the C part. Next problem. Name the quadrilateral. Given the coordinates -2, -3, -1, -5, -4, -4 and -3, -6. So this is A, B, C, D. So -2, -3. 1, 2, 3. This is point A. -1, -5. This is point B. -4, -4. This is point C. Let me just make A above. And -3, -6. Very close to each other. Sorry, -4, -4 will be here. A is here, -2, -3. -2 on X, -3 on Y. B is -1, -5. -1 on X, -1 on 5. C is -4, -4. This is C point. And D is -3, -6. So this is D. Joining them. This is the quadrilateral formed. A is -2, -3. B is -1, -5. D is -3, -6. C is -4, -4. So let us find length of AC. A is -2, -3 and C is -4, -4. So AC will be equal to square root of, this is, let's say, x1, y1, x2, y2. x1 minus x2 whole square, -2 plus 4 squared, plus y1 minus y2 squared, so -3 plus 4 squared. Square root of 2 square plus 4 minus 3 is 1 square. Square root of 4 plus 1, which is square root 5 units. Similarly, we can find the side lengths of other sides and we'll get that AC is equal to CD is equal to DB is equal to AB is equal to square root 5 units. Now, so this becomes either a square or a rhombus. Now find the diagonals. AD. A is -2, -3. and D is -3, -6, and BC. B is -1, -5, and C is -4, -4. So AD will be equal to square root of -2 plus 3 squared plus -3 plus 6 squared, which will be equal to 3 minus 2 is 1, 1 square 1, 6 minus 3 is 3, 3 square 9, so square root 10 units. Similarly, you can find BC, that will also be equal to square root 10 units. So since the diagonals are equal, this quadrilateral becomes a square. So B square is the answer. Next problem. Name the quadrilateral given 2, 4, -8, -8, -5, -1, -1, -11. A, B, C, D. 2, 4. This is the point A. -8, -8. -8 here and 8 above. B point. C is -5, 1 and D is -1, 11. So this is the quadrilateral formed. A is 2, 4. B is -8, 8. C is -5, 1 and D is -1, 11. Let's find the side AC. A is 2, 4 and C is -5, 1. AC is equal to square root of -5 minus 2 squared plus 1 minus 4 squared, square root -7 squared plus -3 squared, square root 49 plus 9, which is equal to square root 58 units. Similarly, we can find the other side lengths and we will get AC is equal to CB is equal to BD is equal to DA is equal to square root 58 units. Now the diagonals AB and CD. A is 2, 4 and B is -8, 8 and C is -5, 1 and D is -1, 11. So if you find diagonal's length, AB is equal to square root of 2 plus 8 squared plus 4 minus 8 squared. So 2 plus 8 will be 10, 10 squared will be 100 and 4 minus 8 is -4, -4 square is 16. So 100 plus 16 is 116. And CD will also equal 116 units, square root 116 units. So AB is equal to CD is equal to square root 116 units. So therefore diagonals are equal, sides are equal, the quadrilateral is a square. I hope you can practice more problems on identifying quadrilaterals given coordinates by graphing now. Thank you for watching. Have a great day. Bye-bye.